Hello everyone, welcome back. So in this video, we're going to talk about ADSL. Okay, so ADSL is this is Atom Implementation Guidelines version 1.1 I have right now. So what is the ADSL? ADSL is a subject level analysis dataset. Okay, it contains one record per subject regardless of the type of clinical trial design. Okay, the label of the ADSL is subject level analysis dataset. Okay, it contains subject level populations, flags, planned and actual treatment variables, demographic information, randomization factors, subgrouping variables, and important dates. Okay, so this is basically it having one record for every subject. So and this have all the information related to treatment and randomization factors and some related to the dates. Okay, treatment related dates. Okay, let me continue with this program by using the Python language. So I'm here, I open the VS Code here. In VS Code, let me bring that file which I already created the programming, which I already built the programming. Because for me, if I start explaining each, okay, so I'll explaining that ADSL by using the VS Code Python here. So if I open the file, so let me, because I already created the programming part. Okay, so here let me explain you the program one by one. There are plenty of benefits by using the VS Code comparing to PyCharm or some PyCharm and also other platforms on Anaconda. So because the reason why I'm using the VS Code, because here you can have directly open the Jupyter. For example, if I ask you for the new file here, so you can open the Jupyter notebook. You can also open the Python file, but when you're checking the data set, data frame, actually we call as data frame in Python language, so we can't able to see everything in the Python file. So best you can install this VS Code and open in the Jupyter notebook. Okay, for example, if I ask you to open the open files, and there is some extensions we have here. Here we have R Markdown, R Document, and Jupyter Notebook. I'm using the Jupyter Notebook because the reason why I'm using the Jupyter Notebook, let me show you here. Okay, so first what I'm doing, I'm removing whatever the data sets, data frames are present in the previously. So I'm removing by using the percentage f star hyphen, and you see there are two star marks are here. So this is related to the Copilot. Is asking for generating the AI, because when you're asking generative AI here in the Copilot, it will give the automatic, like if you ask you to, like for example, how to reset the remove the previous data frames, it will give this code directly. Okay, that is a cool feature we have in the VS Code. Okay, let me run this one first. So when you want to run this one, you want to click on here hyphen like run symbol here. Okay, so it will give, when you see the tick mark here there, that is means your program run correctly and there is no error has shown. Okay, so we continue with this program here. So before that, I want to show you the specification. In the specification, we'll be having almost like I think it's 56 variables I have to derive. So there are some predecessors, so the basically is coming from the DM dataset. So we don't want to consider right now for the predecessor, because the predecessor is automatically generated from the DM dataset. So let me filter out this one. I'm removing the predecessor from here. Okay, now we have very less variables to create. So there are some variables which are assigned, because if it is this part, we have to assign the this part, like the number part. Okay, so those are the assigned ones. So majority of them are derive one. Okay, so the derive one we have to create a lot. Okay, let me continue with this one by one first. So before doing any programs, it is good that we have to start doing the logging, because the problem with this VS Code, we cannot generate automatic log. So I have to do the manual wise. So here I'm just stopping the whatever the log we have it before, we have it stop, then we run the new log. So Adam is the log file. Okay, Adam.log file. So when I check, maybe I can change back to ADSL log. I'm not sure. ADSL log. Okay, let me stop first logging. Okay, then we are on this ADSL log. Okay, so when you go to the folder here, and here we have logs, so maybe we can remove this part, we don't need it. Okay, so we have a log, so it is recording everything inside the log for the tracing purpose. Okay, so before we continue with this programming, we should need um, few packages to be installed either. So first, for the data frame, most of the data frames we are using, right, so we should need a pandas. For any statistical and assigning purpose, we need a numpy, and if we have any date related issues, we need to do it date time. And this is having the OS, because if it is OS operating system path, we have to calculate, we have to check. So we need OS and pirate start. If we want to read 7b dat, we have to get this library to install. Okay, so to install you have to go to the terminal here, or new terminal, for example. So here what we can do, maybe you have to do like here, pip install pandas. Okay, you have to do like this, then only you can able to generate. Or what you can do, you go to the command prompt, cmd here, you go to command prompt here, you click on Python. Okay, then you have to download install pandas. So you can do either this way or that way, is up to you how you want to install, because I already installed, I don't want to do it. So now I'm I'm trying to bring this I'm just assigning the path where exactly the datasets are present. So either raw SDTM and datasets, there are some already datasets are present in our folder. So we have these datasets, so we're trying to get those ones. Okay, then we have SDTM datasets, to get this, because the Adam source datasets will be the SDTM datasets. Okay, so this is the dataset I'm just copied from here. So for example, if I Python click on course SDTM, so I directly copied here and here, then I run this one. So it is taking some time, because basically it is importing all these libraries, right? So maybe I can improve, I can just wait, maybe you can understand. Okay, now you see here. Okay, next we have to read SDTM path to import into the VS code. So for that, the SAS SDTM, in SDTM most of them are in SAS 7b dat format, right? So the SAS 7b dat format, in order to read them, we have to create a class object. So one class object we have to create. This works similar like how we do in the macros. So what I'm trying to do, I'm creating a one macro kind of so we call as a class object in a Python. So what does it do? It create one macro. So the macro, how it works, like instead of, you can also write pirate stat to directly uh, reading that SAS7b dat, but what I do, I just try to get that SAS7b dat into the VS code by using this simple class object. Okay, so if it is a list directory, sorry, in SDTM path, okay, this is for file. So files, if it is ends with the SAS7b dat, okay, and dataset name is replaced with missing value here, SAS7 point. So we'll be having, for example, dm.7 SAS but replaced with missing, that gives dm only. Then we have OS, this is OS path like users. Then we have a path SDTM path, so this is SDTM path and join with the file, which is dm. Okay, then we are reading read.7 dot, then file path, this is the file path, which is the dm. In from the SDTM path we're getting the dm here. then the data set we're going to have in the data frame from whatever the data set name we get here. So it is giving into the df from the sdtm data sets. Okay, so we have to run this object. So this is a simple class object. Okay, so what I do, I take this one and I'm using here to get the dm dataset um, into the VS Code. Okay, so what are the dm dataset, what are the datasets we required? We have to get in from sdtm path by using sdtm datasets. Okay, so you have another option also, you can do it. You just copy this part. You have to use yeah, sdtm path slash tm. So you can also do it from here as well, so it's up to you, but this one is quite straightforward because we already created we don't need to do every time with the same thing is repeated. It's easier if I want to do get with the hdtm datasets. For example, if I want to do access the raw dataset, I put raw datasets here and I put raw path. So it is easier for me to create one kind of macro so that I can able to do it continuously. Okay, so let me remove this, make it comment out. I don't want to get this one. Okay, so now run this one. So we have run successfully. When you check the outputs are here, view data. So you will be able to see this dm1 ds face sdtm dataset supplementary data. So for example, if you want to get the dm1 here, so this is the data wrangler extensions. In the data wrangler you can able to see all the data of yours, and the good part is you can able to see this, what are the missing, if there is any missing values, and if you have any distinct value. For example, a202006, it has only this value only here. Okay, so 26 only this value has here. So that is a one, and you can able to see the distinct value, and you also see how many percentage of there, and it gives a clear cut statistics as well, which is very cool to check the data wrangling. And you have to report an issue and export as a file directly from here. And if you want to edit, you can also editing from here, and you can change, like if you want to add drop, and you can able to see the statistics. For example, how many counts are 40 to 45, and all this variables are you can able to, and you see here screen failures and remaining is 74. So I can able to see the distinct directly from here, and here you can see there are two yeah, possible drugs are present here, the defining 37 and remaining is are missing. So yeah, actually, so I feel this is very good comparing to the SaaS, because I can able to see directly from here, and I can also do some operations. You can start ascending order, descending order, add filter, and most of the part you can able to do it from here only, from the dm1 part you can do. For example, if you go to the editing here, so editing, what does it do? It's asking you can just asking directly the copilot, like I want to remove for example, age column. So if you do like that, so it gives directly the code. You just copy this one and paste it here and run it. That's it, so simple. And you can also have some option, run code and apply. So yeah, that is a cool thing, right? So I feel it's very good by having a hands-on copilot by doing this operation by using the data wrangler. Okay, let me close this one here. Okay, okay, maybe I can go back to the viewing option here. Okay, that is the one of the good thing. Then we continue with this one. So what I'm doing here, because I'm trying to merge with the supplementary DM with the DM1. So this is the first step we do when we're creating the ADSL. So I'm using the pivot table here. The pivot table works similar like proc transpose by using the unique subject ID and QNAM. Okay, so there are some age function is first. So then we have to go to reset index. So when I click this one, so before I view data here, and here we have a supplement DM. In the supplementary DM we will be having 619 rows and 12 columns. So what I'm doing here, so all this information was coming into the ID wise, and this q all comes to the bottom of that. Okay, when you check here, so view data, so supplementary DM trans here. So here we have see this column names, then we have the values for those ones. Okay, so because as per the specification, we have some variables to get from the supplementary DM here. So this one is come from the supplementary DM. You know, that's the one of the reason we have to get this one from the supplementary. Okay, okay, let's continue with other variables. So now what I'm doing here, I'm merging with by using the pd dot pandas. Pd means the shortcut of pandas. So here is a pd, right? Yes, so the pd is pandas and the merge is a function of the merge. So we are merging with the dm1 and the sub dm trans by using our unique subject id, and how we are merging by left alignment. Okay, so when I click this one and when you check dm2 here, so we'll be having 41 columns and 116 rows. Okay, so all this information was added here at hospital, everything is there. The only problem I see here, because I don't see the labels of this variable in the data wrangler, I cannot able to see those ones. Maybe we can able to see later on, but I'm not sure. But for now I cannot able to see these ones. What if I export? Either you can do CSV and Parquet. Okay, so that is one of the drawback from here. Okay, let's continue with the other ones. Okay, so thereafter what we can do, we just copy, because this is a copy function which has the similar dm2. We're creating dm3, we're giving the new name as dm3. Then so the dm2 dm3 will be having the same here. It is like a set option. Okay, so then what I can do here, i'm just trying to um, I'm just trying to make age group here, for example, age group. So here in the age group, so when you click on that, just a bit here. Okay, so if age is less than 40, then set to 40 years old. Else if it's greater than equal to 40, then set to greater than or equal to 40 years old. So if you need to check what exactly the dm3 has, so in the dm3, wait, okay, so go to the dm3 here in the data wrangler. So you need to go to check the age variable. So if you go check age here, now we have there are uh, plenty of values here. So we have 48, 39, so all of them here. So what I do, I just trying to make, if it is less than 40, okay, there should be no missing values. Less than 40, then we consider as 40 years old. Else we were taking as a greater than or equal to 40 years old as per this specification. So here in the specification is greater than or equal to 40 years old. And I'm here using the numpy. NP means numpy for doing this statistics assignment. Okay, so dm3 age not equal to any, it doesn't have any missing values. Where dm age is less than 40, then we giving as a 40 years old, because we are considering as a numpy, so this is not considering the floating as well, because in the dm3 we have floating here, the floating 0.10, but that is look like 47 only. So there should not be any having So all of them are distinct values here, so they should not have 45 distinct values, so we should not have any point 1, point 2, something like that. So for that reason we're just putting 40 here. Then if it is 40, then we're giving as a 40 more than, if it is not less than 40, then we're giving as a more than 40 years old. Okay, let me run this one. So we have for DM3 there. Then if you check the DM3 again, so you can, if you go to the age group 1 here, in age, you can able to see this one. Okay, so you have 40 less than 40 years, greater than or equal to 40 years, so like that. So I keep it DM3 open right now for, so next variable will be having sex n variable. So if it is sex equal to f, then set to 2, else if sex equal to m, then set to 1. So it is also the same pattern we use. So dm3, if so dm3 is a data frame, that is the data frame we have, and that is the variable of, so the here you are using the map function here. If it is and this is in the dictionary format. Okay, so if it is f, then we give it as a 2, and if it is m, we give it as 1. This is directly assigning. Okay, and when you see there is a dm3 this bracket and having the variable you are going to create, that is a section and age group 1. So they should be in this format, because the variables you are going to create in this format. So this is the variable you're going to read, and this is the variable you're going to create. Okay, so make sure it is in the brackets, like or list bracket or tuple bracket, I don't check. Okay, so this is the list. In the list we have a variables. So here we continue with the next variable. So in the next variable we'll be having the race variable. Okay, so if the race is American Indian or Alaska Native, then we give it as race 1. So what I do, I just copied everything here. So the race mapping, so in the dictionary format, if it is American, I'm giving 1 and 2, like that. I'm creating race mapping 1 kind of format here. Then what I do, I just apply race mapping directly here instead of doing like this. Okay, so I have created the race mapping. So let me run this one. So you just need to refresh the data, then you check. We have section variable, and also the rest of the field feature we have. See, there are plenty of them here. For example, most of them are 5/5 Asian, so remaining ones are 4 counts and 3 counts, they are missing. So there are 2 distinct values for these ones. Okay, next we continue with the next variable, which is in ethnic. So in ethnic, Hispanic and Latin, then ethnic. So this is the one, and I'm just trying to copy all this part, and I also created the same pattern with the price mapping. So I'm doing the similar pattern. So let me run this one. So when I just trying to refresh again, now I have next two variables are here. So there are total 3 distinct values present in the DM3. Okay, maybe if you want to check, double check with ethnic variable, you can have a check here as well. So here we have maybe I can go to directly from here. So I go here, ethnic variable. So here you see the Hispanic and Latino is our 78%, not Hispanic and Latino 22%, and unknown. So there are 3 distinct values. So that's one of the reason um, it has a 3 distinct. So ethnic, for example, if you go to ethnic here, so you see here there are 3 distinct values. So 1 and 2 and 3. Okay, so basically representing is 1 and 2 and 3 unknown. Okay, let me continue with the next one, which is we are assigning going to the treatment. Okay, and when you check the specification here, okay, let me go back this side. So these 3 are completed. these four are completed. Maybe I can just try to okay, keep it like that. So next, sorry, now can I continue with this part? Okay, so here what I asking for the treatment plan treatment for the period 1. So if arm-CD equal to TQ, then set to tefnoquinine, and if it arm-CD equal to placebo, then set to placebo. Okay, so what I do here, DM3, this is the DM3 and TRT01P, and numpy I'm using. So where functions, okay, so where arm-CD equal to TQ, then we are giving as a tefnoquinine. NP where DMQ equal to placebo, then we're giving as a placebo, else none, remaining as a none. Okay, and also we're doing the TRT01P, which is also the same pattern, but we're giving in the numeric format. So tefnoquine, then TRT01P one as a 1. So I'm doing the same thing here. If TQ OMCD equal to TQ, then we're giving as a 1. If if OMCD equal to placebo, then we give as a 2, and else we're giving as a none. Okay, that is for the planned treatment assignment. I hope you understand. Then if you go to the TRT01A, in the TRT01A, if actom CD equal to TQ, then we give it as a tefnoquine, else we're giving as a placebo. Okay, so here also similar pattern. If actom CD equal to TQ, then we're giving as a tefnoquine, and if it is a placebo, then we're giving as a placebo, else we're giving as a none. And the similar pattern we give for the actual numeric format, also the same thing. So here we see, if it is this one, then we give it as a 1, and if it is this one, we give it as a 2. Okay, so these four variables are TRT01P, and these ones are done. Okay, let me run this one up. So go to the DM3 and refresh the data, and you see all our informations are the planned ones, and the planned ones numeric, and the actual one and actual one numerics. Okay, so we got all this information, and you see there are distincts are only two. They will be having tefnoquine and placebo, and the remainings are missing 30%. Okay, so which is a cool feature I see, and it is easier if you can able to work on it. So here we have what we have. So this is next we're gonna do with the dates. Okay, the date parts. So these one, the time and exposure of the treatment, date of the first exposure of the treatment, date of the last exposure of the treatment. So this part we have to do. So let me continue with this. So set numeric date RFX STDTC. So this is integer part. Okay, so we need to check the control terminology, because the date part, most of them are, they have to keep it in the ISO 8601 format. Okay, for that one we have to create I'm creating the function, one kind of date structure function here I'm creating for the both, for the TRT SDTM time part and the date part, date of the first exposure and the date time. So I'm creating the one function, so that I don't want to do it every time, and I applied only those things whenever required. Okay, so what I'm doing here, I'm creating the one functions called as a this part called pos a ISO 8601 date and time. So what does it do? Basically it's considering the pandas library, and if there is any missing values, there is a structure data structure, because this is the variable we're going to keep it, for example artifacts here. Okay, so if it is there is a missing values, or there is a NA values, or there is completely missing values, we have to return as a none, nothing. There is no need to do it anything else. Try if it is if we have a format, if it is else if there is no missing value, we have to apply this format y percentage y and percentage m percentage d and time separation and hours, minutes, and seconds. This is the format we're going to apply for this date structure, like artifacts, for example. Then if else, if it is a date structure, If it is completely date structure, like if it is a ISO 8601 format only the date, you write nothing here. Okay, if there is no date structure like that, we have to apply percentage YMH in the time frame manner. Okay, if there is no nothing like that, we have to keep it. I mean, if he has a similar pattern, then we have to keep it as nothing. So this is a function we have, just like it also works like a macros in the SAS macros. So this is the macro we're creating, and this is the execution we have to do it. It has to go because instead of date structure, we're giving us RFX DTC, RFX ENDTC like that. Okay, so this is for the date and time, and this is for the date only. So what is doing? It is doing the same thing. If there is any okay, so here we have doing the date only part. Okay, so let me continue with this one. So if RFXS, because this is the TRT SDTM we are going to create, and RFXS TDTC apply the date time format IS8061 format. So this function we are applying, and the TRT SDT is a parse date only format. So this is the only format we are going to apply, and the similar for the TRT EDTM and also for the TRT EDT. Okay, let me run this one. So there is no difference I have seen. So when you check the DM3 and when you refresh it, so you'll be having the TRT SDT in the SDTM in the time date and time format, and also the TRT SDT in the only the date format. Okay, and also the similar for the TRT EDTM and TRT EDT. Okay, so when you check the specification here, so we have done up to this part. Okay, so we are done up to here. Sorry. Okay, so let me make green. Then we have to calculate the TRT duration. So TRT duration is nothing but the subtraction from the end date time and TRT SDTM plus 1. Okay, so when I go to here, okay, so this is, we not subtracting the time, we are subtracting only the date part. Okay, so we remove this thing, we don't want. Okay, so yeah. Okay, let me continue the TRT EDT minus TRT SDT plus 1. Okay, so here the TRT duration D, that is a new variable we're going to create, and we're using the numpy. So where TRT EDT not equal to missing and TRT SDT not equal to missing, so the PD date time, the TRT EDT minus TRT SDT plus 1, that is the duration we calculate. Okay, so when you check here, okay, so you can able to see the difference. So 0730, there is only one difference, right? Plus 1 and 1 plus 1, and there's missing values and missing values. So if it is a 3 minus 1, it's just 3. Okay, so this is the TRT duration. Next we continue with the next variables. Okay, so I'll make this one as okay, so next we can continue with this screening failure and safety population flag. The reason why we are doing this one first, because the randomization flag and the data of randomizations depends on the coming from the disposition data set. Okay, so for now we are doing with the DM, right? So we are considering only. Okay, so it seems like we have to do with the DM part first, then we can continue with the dispositions, because the remaining intended treatment population flag. Okay, so the randomization flag, it requires the disposition. So we have to derive first with the disposition data set, then we continue with the screen intended population flag and also the per protocol for flag. So for now we're gonna do only these two part. Okay, screen failure, this RF SIDTC set to RF SICS not equal to missing, and the other one is the screen safety population should be, there should be no treatment missing values. Okay, so what I did here in the DM3, so where RFS is not equal to missing and RF is not equal to NA and not equal to missing, then we give it as a Y, otherwise none. And we do the same thing for the population, but we're taking that reference start date, treatment start date. Okay, so the same pattern. So let me run this one. Okay, if you refresh this data, and you can able to see the screen failure and safety population flag. Okay, So let's continue with the next one. Now we're going to create the vital signs reading. So we have done these two. So we have done these two. Next we're going to create these ones, baseline. So all related baseline. So these three we will be doing with the vital signs. Okay, height and weight and BMI. These three we are going to consider from the vital signs. So what I'm doing here, I'm creating the filter first. So I'm trying to make uh, trying to take. So here what is asking to calculate the BMI. So we the standardized numeric format where VS tested is in the equal to height and weight only. Okay, so it should be in the height and weight. So I'm filtering out for VS test study is not in height and weight, and visit screening day to 1. Let me check, is there any mention? Yeah, here you see these are the screening for the height and weight first, only the screening part day to 4 1. So when you check the VS part here, if you go to the VS part, so now we can check visit. So visit we have total distinct is 29. So there are a number of distincts we have here. The screening day, so let me filter off for only for the screening part. Okay, contains. Okay, let me select this one first, then add a filter, contains only this part. So we will be having almost like almost like 848 rows now, if we have considering only the screening and day one. Okay, so what I do, I just count, then I select only unit subject ID, VS test CD, and standardized numeric result. Okay, then what I'm doing here, I'm just trying to change for the VS filter rate. Okay, for the, let me run this one first. Let me divide first. I'll run this one. Now you can see the VS filtered. Okay, let me open this VS filtered here. Now you'll be having only three records, three columns. Okay, in the three columns, what I'm doing here, I'm just I'm transposing them because I want height and weight should become on the top, and the values are going in the bottom of them by unique subject ID. Okay, so let me run this one. Okay, so VS trans there. Okay, so if I open the VS trans data, so here we have VS trans data, right? So now you can see height and weight are coming on the column wise, and the values are here, and you can also see the skill features, or how many counts are in between 153 154. So the visualization also part. So the what is the minimum value and what is the maximum value, so that is in the bar chart. So I can able to see from the data wrangler. So here is, which is very good. Okay, now next what I'm doing here. So if height in VS trans, like in the column, and the weight in VS trans column, and the BMI. Okay, so we are considering BMI, weight of the height into 2 into 1000. So this is the formula we do to convert the BMI by using the height and weight two columns. Okay, then what I'm doing, I'm just trying to rename as per the coding, as per this from the baseline height and baseline weight and baseline BMI. Okay, so I'm trying to do this these things because I already done with the BMI part. So let's continue with this part. Okay, so now um, next what we do. So when I check the VS filtered here, not VS filters, DM3. When I check the DM3, so we'll be having, okay, maybe I can, I'm adding at the end, I guess. Okay, sorry, I just tried to keep this one here. I remove this part. Okay, just add here, I run it. Okay, so when I check the VS trans, view vs trans here. Okay, now we got the values, all the values are required. Okay, I'll keep the floating point like this only, but at the end we can able to change. Okay, for now we just keep it as it is. So the next one is end of study status. So these three are done. So these three are done. Now we continue with so this is coming from the supplementary DM. Okay, these are three are coming from the supplementary DM, which we already have it. Okay, so you see here everything is supplementary DM, supplementary DM. Okay, so next we continue. Oops, sorry. We continue with end of study status and discontinuous reasons. So there are three ways to derive. So here we have three conditions basically. Set to completed if a category of the disposition event is a disposition event, and subcategory of disposition event end of study or early termination, and standardized disposition upcase equal to completed. Okay, so we are deriving the end of study status. Okay, so else discontinued if a category of disposition event, and so if it is the same thing, disposition event and end of study or early termination, and standardization disposition not equal to completed. If here is equal to completed and here is not equal to completed, so there are two conditions are there. If it is not equal to completed, then we have to give it as discontinued, and if it is completed, we have to give it as a completed. Else set to screen failure if a category of the disposition event and a DS cat screen failure and transaction DS code is missing, is not missing. So if it is a screen failure, then we have to keep it as a screen failure. So that these three conditions we have to do it. Okay, so here what I did here, the DS cat is a disposition event in the uppercase, and the DS is subcategory end of study. So I make it as a copy for the DS EOS. Then for the DS EOS end of study status, the DS decode is completed or discontinued. Okay, so I if DS decode is completed, then I give as a completed in the proc case. Okay, so here what I did, completed in the prop case. So it's asking for prop case, right? So discontinued, completed, prop case. So I done these two conditions right away. So here I did the completed and completed both of them. Okay, so here I did two conditions. The next condition, what is that one, is asking for screen failure. So we have to get the screen for DSK screen and standardized DS2 not missing. Okay, so we will continue with that one later. For now we just meeting these two conditions. So here we have the next variable. So the next variable is discontinuous and reason. So discontinuous reason for the discontinuous reason. Okay, so here what I did, set to standardize dispersion term if a category of dispersion events subcategory end of study and is not missing or not completed, else set to null. So we have to DS decode standardized disposition. So we if the subject screen that is set to missing. So what I'm doing, so I'm meeting because these two are looks like a similar thing. So I'm doing the same condition on the same way, in like same location. So here what I do, so DS EOS DS decode. Okay, so if it is the same thing, then the P, because this is the same thing, right? So it will be the similar pattern. So the reason for that, the reason for the specific discount set to reported term if it is disposition of state terminated and DS decode other. Okay, so if it is DS decode other, then we have give as a DS term. I hope you understand because it's quite a complex thing, but what I'm trying to do here, I'm trying to mix up these three, this one end of study status, discontinuous reason, and discontinuous specifications. I'm trying to keep it three one at one place. So because it has the similar conditions, the DSCAT disposition event and DS subcategory of the DSCAT is end of study or early terminations. So either if it is equal to completed or not equal to completed, I did these two conditions and I leave this one at the end. And the similar pattern I did the same thing for the, because it has the same conditions at end of study time and disposition event are not equal to completed, and this one also have the same thing. So I did these three at the same place. Okay, let me run this part. So when I check ds eos, okay, so now you will be see here ds end of study status completed, discontinuous, and also the discontinuous reason for planned, okay, screen failure, sorry, reason specific discount for the reason. So these two have we have done, and this one also we have done. Okay, but we have one condition, but we do this one at the end. If EOS TTT and the screen failure. So here we have another condition. If you end of study status missing and treatment start date not equal to missing, then end of study status is equal to ongoing. So that is obviously because if there is no end of study status thing, but if the TRT is HDT is not equal to missing, obviously the trial is ongoing. So the next was screen failure. So I'm here I'm doing the screen failure, the another condition, right? So this condition, screen failure conditions. So what I did, screen failure, so disposition event and the dscat is equal to screen failure, then I give as a screen failure. Okay, so dsSCF, that is for the screen failure. So there is no screen failures in this particular project for now. Okay, so next we have to do, so here what I'm trying to do, I'm just trying to combine with this concatenate function by using the pandas concatenates by using ds dscf. Okay, so the next what I do, I just trying to creating the randomization flag, which we have we did not do before, right? So here for the randomization flag, now we are taking the disposition dataset dsd could randomize and dsstdtc is not missing, then we set to y. Okay, so here what I did, so with dsd code randomization and they should not be missing for the dsstdtc, there is no na and as well as there is no missing values, then we give it as a this file as a ran. Okay, so this is the ran data set run. So next what I did, if rndt, so this is the date format we are creating here. It's a date of the format, so set to date part of the dsd equal to randomization, and this is the same thing. So rnddt dsttc apply, and we are considering only the date part, passive date part. Okay, so we are considering only the date part, so I applied that function here. Apply this is the function to apply if you have functions are created in this program. So this is the passive data apply, then I'm creating the randomization flag equal to y, and also for intended treatment population also it is set to y if r and d vfl equal to y. So if it is y, this is also y. Okay, random y. So then we are then what I'm doing here. Okay, so the finally data set will be that there should not be ran data dgt, there should not be na present into this ran date variable, and I'm selecting these 4 variables from here. Okay, so when I check the ran data set, when I go to check the ran data set, so in the ran data set we'll be having only 4 variables we have selected: the ran date and randomization flag and inter-treatment population flag. Okay, so next what I'm doing here, okay, so we are finished, we are completed, so we are completed these two variables. Okay, okay, then I also completed this intent to population and no, not the per protocol, it's just intent to population, intent to treat population flag I have completed. So next we have per protocol population flag. Okay, so let me continue with this one. So because it is having the day 14, so I'll do this one later, because we have to derive here the remaining End of study date also we have completed, right? Because I can show you here. We see end of study date. Yeah, here we have applied past date only, right? So end of study date we have completed. So next, what I'm trying to do here, so I'm taking the subject visit. So visit num equal to 15 because I'm considering I'm doing this COVID-14 because since this is a COVID related project, so we have a two. So this one is coming from the DM, so we don't need to do this part. So we have to do the 14 flag and 28 flag. So here, clinical recovery conditions, cough and shortness of breath, difficulty breathing on or before day 14, then flag as Y, else at no. So we have to clinical recovery conditions. We have to get um, this condition, this filtration. We have to do it or before 14. So what I'm doing here, I'm considering the subject visits. I'm filtering out the 15th visit number in 15, and if there is any duplicates, I'm dropping them. Okay. So next for the COVID 14 day flag. So here I'm taking the face data set. We have face data set here. So in that face data set, what I'm doing here, FAOBG. So if I go to the column FAOBG, so here we have all this related to the symptoms, related to the findings about. Okay, so here what I'm doing, I'm considering only the cough, shortness of the difficult breathing. Okay, so I'm taking those filtration. So such ease in the cough and shortness of breathing, and visit num is less than or equal to 15, then we give it as a FA1, then FA1 equal to COVID-14 flag equal to Y. Okay, then in FA1 we are keeping only unique subject ID and COVID-14 flag variables, and we are removing the duplicates. Okay, that is for the COVID day 14 flag. And similarly for the COVID day 28, I'm just giving the filtration to less than or equal to 28. I'm also taking only these two variables, COVID unique subject ID, COVID 28 flag. Okay, let me run this one. Okay, so now we have created two different data set, FA1 and FA2. Okay, so here FA1 is related to. Okay, so we have separated the FA1 and FA2, two different data set for the COVID-14 flag and COVID-28 flag. Next, what I'm doing, I'm merging all of them. So I'm merging with first with VS trans, then DS final, then RAN, then SP visits, then FA1 and FJ2. So now I'm creating that per protocol flag. Per protocol flag, what is the condition is asking for? Intended clinical, like for example, if ITT FL equal to Y and also subject completed day 14, then per protocol flag equal to Y. So the day 14 is completed means obviously the visit 15, right? In the SV visit, what we do, we took the visit 15. This is a visit 15 variables. Okay, this is sorry, visit 15 rows. So all these subjects are completed 15 days. Okay, so here a visit 15 equal to both, then DM4 intended treatment population flag equal to Y, then we give it as a per protocol flag equal to Y, otherwise none. Okay, let me show you this one DM4 clearly, you can understand. Then what is ongoing process? So remember we left one condition here for end of study status, right? Here the last one we have so here end of study status equal to missing and TRT not equal to missing, then end of study status equal to ongoing, right? So this part, we did here. So end of study status and the DM TRT is not equal to missing, then we're giving as a ongoing, then we're considering only the DM4 end of study status. Okay, then fill missing intended treatment population flag if TM4 is not equal to NA. Okay, so let me run this one. Okay, so maybe I have here something. DS final is not defined. Okay, let me run this DS final. Okay, so here what I rerun the DS final again. So I run back all this merging part. So now it seems okay. So DM4, when I open the DM4 here, let me check the DM4. So in the DM4, so we have all that information required as per the for the final data set. Okay, so it will be the 70 columns. Okay, 70 columns. Okay, so then we are selected only the required columns. So we have selected based on this one. Okay, so we this one protocol is done. Is there anything else we have to do it here? So these two are also done. Okay, so if we go back, so everything is done. So we have selected all of them for the I'm creating as a final column for that one. Okay, so what I'm doing, I'm existing columns. So call for call in final columns in the DM4 column. So what I'm applying that existing column for call each column. So here when you check the existing columns, so when I check the existing column here, you can able to see all these labels. Okay, now all these variables are here. So I'm applying that variables to this DM5. So if I open the DM5, so you'll be having that each individual variable applying the labels. Unfortunately, I cannot able to see that the variables are for each individual variable. Okay, so we continue with this column labels here. So the column labels are applied, all the labels the same. So because I'm applying the column labels here, so the column labels I'm applying the DM5 for the attributes by using the attribute functions and giving as the column labels here. Okay, so the DM5, then finally we check the DM5 here. The DM5, yeah, you see, even if you apply that label, so you don't see that labels are here. You're just giving that um, the column names. Okay, okay, so if I go here, columns, so even here also you cannot see anything. Okay, so I close this one back. Okay, just leave it as it for now. Then I'm creating this output to ADSL1 SAS data source. This is the Atom path we have derived on the top, right? So on the top we have derived and Atom path. So we have derived Atom path here. Sorry. So that is Atom path. I'm giving the final data set name ADSL dot SAS7b dot. Okay, so in that, so if you want to create a CSV format, I'm also creating the same thing here. Then if it is any problems in this creation of the ADSL, then it gives the error by giving the message in the print functions. So even the display basic info about the data set all this information will be given here in the bottom. So you can see ADSL dataset created with 116, how many DM5 subjects and how many columns, the variables and columns. So and where is it saving, that is saved in to this output path Python, where exactly is going to save, and also the dataset info. So the shape is like the how many rows and how many columns, and the columns are given, and how many what are the columns are given, everything is printed here. So when you go back, check that ADSL. So here we have Python program. So in the Atom data, if you Python here, if Atom data sets, so you'll be having this part. Okay, so this is the one data set we have created for this ADSL. So yeah, yeah, there are some confusion in between, but hope you understand. And if you start doing this practice, you will be understand more clearly. Thank you so much for listening.